assignment, IGCSE Chemistry Paper 2-3, May, June 2021. Okay, without much ado, let's begin. The first question says, a gas is released at point P in the apparatus shown. Here is cork. This is the point P where the gas is released. A damp universal indicator paper is placed here. Now, which gas turns the damp universal indicator paper red most quickly? Which of the gas will turn it red most quickly? Is it ammonia? No. Because something that will turn it red is an acid. Acid turns the blue litmus paper red. So ammonia does not turn red. Okay, chlorine, no. Hydrogen chloride gas, yes. Yes, because this is acid, right? Right? So this will be C. Red. Let's put it red. Okay, so that's that for that. The first one is hydrogen chloride gas. Okay, now question number 2. Is a 1 centimeter cube sample of substance X is taken. Now this is sample 1. Now X is then converted to a different Frisco state, and a 1 centimeter cube sample is taken. This is sample 2. Sample 2 contains more particles in the 1 centimeter cube than sample 1. Sample 2 contains more particles in the physical state than sample 1. Now, which process caused this increase in the number of particles in the 1 centimeter cube? Could be boiling. No, boiling will reduce the particle. It will make it gas. So A is not correct. Condensation of the gas. Yes, when gas condenses, when it cools down, it comes from gas to liquid, right? Evaporation, no. Sublimation, no. So I think the most correct answer would be B. Condensation, because when a substance condenses, it moves from gaseous to liquid. So there will be more particles in the liquid than in the gas. So we'll go to question 3. Question 3 says, which statement about paper chromatography is correct? A solvent is needed to dissolve the paper. That's not true. Paper chromatography separates mixture of solvents. The mixture of solvents. C, the solvent should cover the baseline. D, the baseline should be drawn in pencil. I think that's correct, right? We draw the baseline in pencil. It's most correct. Now, element X has several protons. Element X has several protons. So, meaning that element S, atomic number is 7. In actual sense, this is usually like nitrogen, in actual sense. Okay, but let's just, it has several protons, which means atomic number is 7. Element Y has 8 more protons than X. Element Y has 8 more protons. 8 more means 7 plus 8. That will be 15. Y will be 15, right? 8 more. Y will be 15. Right? Now, which statement about element Y is correct? Which statement about element Y is correct? Now, you say Y has more electrons shared than X. That's correct. Of course, why we have more electrons? Because number of protons equals to number of electrons. So if he has 8 more electrons, 8 more protons, it definitely means he has 8 more electrons. It definitely means he has 8 more electrons. So why we have more electrons? Just a minute, okay? My computer is about to go off. Okay. Okay, so we say it means that if you have 8 more protons, it actually means you have 8 more electrons. So Y has more electron share than X. That's correct. Y has more electron in its outer share than X. That may not be absolute. It depends. It doesn't necessarily mean have more electron in the atmosphere, but it definitely has more electron than X. Y is in a different group of the periodic table from X. It depends. That may not be true also. That may not be true. Y is in the same period of the periodic table as X. No, that's not true. I think the most absolute answer here is 1. Y has more electron shares than X. Why will it have more electron shares? We are talking about, if this is where you have the nucleus, you have your proton and neutron here. Okay, the first one is 2 electrons, and then X now have another, after 2 electrons it has another, let's say these are the electrons. After 2 electrons it has 5 more electrons. So I can have 1, 2, for X, for element X, 3, 4, 5. Element X, this element X. So why we definitely have, because we have 2, 8, because it's 50, right? 2, 8, that's 10, and then 5. So there's another share. There's a third share. This first share, this second share for element X. But for element Y, you definitely have 3 shares. This one you only have 2 shares because it's 2, 5. Since the number of protons is 7 and a number of electrons is also 7, if you draw the electronic configuration, you have only 2, 5. Okay, for this one. So you have 2 shares. This one you have 3 shares. Y has 3 shares, right? If you look at them, they both have 5, same number of electrons in the atmosphere. The atmosphere of this one is 5, the atmosphere of this one is 5. See? So A is correct. Y has more electron share. They just say more electrons. More electron shares. This one has 2 electron shells, and this one has 3 electron shares. Okay, so Y has more electron shares than X. That's the most correct one. You say Y has more electrons in its atmosphere than S. No. In atmosphere, this one has 5, and this one also has 5. So B is not correct. You can see B is not correct. Y is in a different group of the periodic table from X. No, they are in the same group. They are in the same group because they end with the same 5. So they will be in group 5 in the periodic table. They end with 5, both end with 5, so they will be in group 5. So it's not in different group. They are in the same group in the periodic table. You say Y is in the same period of the periodic table as X. That's also wrong. You know why? This is wrong. Because to be in the same period, you must have the same number of shares. You must have, this one has 2 shares, this one has 3 shares. So they are not in the same period. So the most correct answer is A. Now we go to question 5. A covalent molecule Q contains only 6 shared electrons. What is Q? A covalent molecule contains molecule Q contains only 6 shared electrons. So it has 6 shared electrons. 6 electrons shared. What is that? Q. Okay, you have ammonia. Here it has a bond with hydrogen. One here. So this one bring 1, this one bring 1. So every point is 2. So I think this is ammonia. If you draw the electronic configuration, nitrogen, nitrogen it has triple bond. Okay, it has triple because it has to gain 3 electrons. It has to gain 3 electrons to obey the octet rule. Okay, so hydrogen bring 1 nitrogen, a bond here covalently. That's 2. 1 from nitrogen, 1 from here, right? That's 2. 1 from here, 1 from here, that's 4. 1 from here, 1 from here, that's 6. So I think the answer is A. Chlorine to chlorine, only 2 shares, only 2 electrons. Chlorine, chlorine to chlorine is a single bond. Chlorine to chlorine, like this, single bond. Chlorine to chlorine, single bond. So it's not. Methane is only 4. Methane is not 6 because carbon and hydrogen will surround carbon in 4 places: up, down, right, left. For this one, so it will be 4 or 8, as the case may be. Water, oxygen, we bond one side with one hydrogen atom, bond on the other side with another hydrogen atom, like this. Oxygen will bond with one hydrogen to one side, and also bond to this other side with another hydrogen. Okay, so you can see this is so the correct answer, water is not correct. So the correct answer is A. We go to question 6. I think we should increase our speed so that we can finish the whole paper. We go to question 6. Now, which statement explains why metals are malleable? Malleability can be ability to differentiate, right? Okay, the atoms release electrons to become cation. No. The electrons are free to move. No. That's not why it's malleable. Why it can be ability to differentiate. The electrons and the cations are attracted to each other. That's not the reason. The layers of the ions can slide over each other. Yes, the layers of the ion can slide over each other. So it can be ability to differentiate. Now we move to question 7. Question 7 says which statements about isotopes of the same element is correct. Isotope of the same element, they have the same number of electrons. Let's take a look at which one can we use. We can use carbon 6, carbon 12. Okay, isotope means element having the same atomic number, the same number of protons, but different mass number. That's the meaning of isotope. Okay, they all have the same number of electrons, so they have the same chemical property. So as we can simply say isotopes are elements that have the same chemical property but different physical property. That's another way of saying it. So they have the same number of protons, same atomic number, same number of electrons, but they have different number of neutrons. So it's a which statement about the isotopes of same elements is correct. They have different number of electrons. That's not true. They have the same electron. So this statement is not correct, right? They have different number of neutrons. Yes, they have different, because to find the neutron, you say 12 minus 6. Here the neutron is 6. 13 minus 6, here is 7. They have different neutron. Here is 14 minus 6, here is 8. So neutron, they all have different neutron. Because to get neutron, you say the mass minus the number of electron or number of proton, you get the neutron. Minus the number of proton, you get the neutron. So they all have different number of neutrons. So this is absolutely correct. They have different number of proton. No, all the proton is same. Proton is same as the atomic number. They have the same mass number. No, they don't have the same mass number. You see the mass are different. So we'll go to question number 8. Question number 8. The element silicon has the same structure as diamond. Silicon has the same structure as diamond. Which statement about silicon is correct? Every silicon atom is bonded to 3 other atoms only. Silicon has a high melting point. Silicon is a good conductor of electricity. Silicon is used as lubricant. It's graphite that is used as lubricant, and it's graphite that has good conductor of electricity. atoms are bonded, is graphite that is bonded to 3, this one are bonded to 4. So higher multiple, I think, is the most absolute one. So we go with this one. Now we go to question 9. Question 9 says 3 ionic compounds of vanadium have the formulae vanadium oxide, vanadium 2 oxide, vanadium chloride, vanadium 6 oxide. Okay. Now what is the charge on the vanadium ion in each compound? The charge of the vanadium ion in each compound. Okay, this first one, the charge will be 1, will be positive 1. This one, the charge will be plus 1. This one, the charge will be plus 2. This one, the charge will be plus 3. Okay, the charge is coming from, see this one, it is bonded, what is bonded with is 1, right? The oxygen is 1, so we have plus 1. Because if you do the vanadium, the exchange, the charge exchange gives the compound, right? So, which means this one gives 1 here, and oxygen gave this 2 to this one. In the essay, you see V, and then this one. So oxygen is 2 minus 2, but even though we don't use the minus also, and while this one is 1. So when you cross multiply, we now have V2O. V2O. So the charge of this one is 1. The charge of this one is 1. Then this one, the charge is 2. This one, the charge is 3. Based on this number, I think the most correct answer is B. Most correct answer is B. Okay, we move on. Because vanadium is a metal, so it has to lose electrons. So when you lose electrons, it becomes positively charged. Now we go to question 10 to save time. In separate experiment, electricity was passed through concentrated aqueous sodium chloride. Concentrated aqueous sodium chloride. Sodium chloride is really like this. Electricity was passed through aqueous. When you hear the word aqueous, means it was mixed with water. Electricity was passed through aqueous sodium chloride, not sodium hydroxide. I wrote sodium hydroxide. This one, sodium chloride. Aqueous sodium chloride. This one. So electricity was passed through aqueous sodium chloride. Is that okay? And multi-lead 2-bromide. Multi-lead 2-bromide. Now, what would happen in both experiments? What will happen in both experiments? Aqueous sodium chloride and multi-lead 2-bromide. Lead 2-bromide is like this. Lead is Pb. Lead is not Pb. What is it again? Okay. So let's see. It says what will happen in both experiments. Electricity was passed through sodium chloride and multi-lead lead 2-bromide. What will happen to both experiments? In both experiments, what will happen is that a halogen will be formed at the anode. A halogen will be formed at the anode. It looks likely, right? Which of the halogen? Because chlorine is halogen and bromine is halogen. You know the halogen family? Group 7 elements. The halogen are group 7 elements. Starting from fluorine. But fluorine is very explosive, so we don't normally talk about it or we don't normally use it. Okay, so even if we don't write it, it's understandable. Usually we start from chlorine. Chlorine, bromine, iodine. Okay, these are group 7, they are called the halogen. Iodine, astatine. Okay, so these are the halogen. These are the halogen. Fluorine, like I put asterisk, is very explosive. So the anode, you know, this will produce what? Negative electron. and negative ion. This will produce negative ion, right? So this ion will migrate to the anode. The negative, for this experiment, this ion will migrate to the anode, and also for bromine will migrate to the anode because they are negative electrons, so they will migrate to positive electrode. They are negative ion, they will migrate to positive electrode. So a halogen will be formed at the anode. That's correct. A metal will be formed at the cathode. A metal will be formed at the cathode. No, that's not true. Right? A hydrogen will be formed at the anode. No. Hydrogen will be formed at the cathode. Hydrogen will be formed at the cathode. Hydrogen will be formed at the cathode. Depends. For this one, it's bromine that will be formed. Okay, for this one. So in both cases, only in the first case that hydrogen will be formed, only in this one. Because hydrogen is less, this one is aqueous. It's an aqueous solution. So hydrogen is less than sodium. So hydrogen will be the one that will be discharged. That will be discharged at the cathode. But however, for this one, no. For this one is the lead that will be discharged. So in this case, why this one is wrong is because both of them are not. But if you look at A, both of them at the anode will be halogen. They did just say chlorine. Both of them will be halogen, which is the first one, chlorine, will be at the anode. The second one, bromine, will be at the anode. So they are called halogen. So that's the most correct answer. Now we go to question number 11. Question 11. It said the equation for the decomposition of calcium carbonate is shown. Calcium carbonate to produce calcium oxide and carbon dioxide. This is thermal decomposition. Okay, you heat this, this is a limestone. Okay, you heat this limestone, you break it down to quicklime and carbon dioxide. What mass of calcium oxide is produced when 10 grams of calcium carbonate is heated? You heat 10 grams of calcium. So they've given us the mass of this one. Okay, so since they gave us the mass of this, we have to find, first I want to write the molar ratio. This is ratio 1. Anytime you are doing mole, you must write out the molar ratio first. Ratio 1 to ratio 1 to ratio 1 to ratio 1. They are all ratio 1 because there's no 2 behind these, there's no 3 behind these, there's no any number of molecules behind any of them. So they are in ratio 1. The next step is to calculate the number of mole of the one they've given you the mass, calcium carbonate, this one. So we're going to calculate the mole. Okay, you know mole is mass over molar mass. Mole is equal to the mass over molar mass. So I just write M over mm. M over mm. So the only thing we need to calculate now, we need to calculate the molar mass or molecular mass of this one. So here you use your 4-figure table, your periodic table, sorry, not 4-figure table, your periodic table. So calcium is 40, right? So you say 40 plus, you can check, you always check the mass of each one, plus carbon is 12, right? Carbon is 12, so you say plus 12, plus oxygen is 16. So but 16 you multiply by 3. Because of this 3, you multiply the oxygen 60 by 3. So I can open a bracket 60 times 3. 60 multiplied by 3. So I want to get the molar mass so that I can calculate the number of mole of calcium carbonate. So what do we get? 60 times 3, then we add this plus this, we get 52. 60 times 3, what do we get? 48, right? 48 plus 52, we get 100. So the molar mass of this will be 100. The molecular mass of this will be 100. So to get the mole, we just come and substitute it to this formula. We say our mass of calcium carbonate which has been given to us is 10 grams. So you say 10 over 100. That would be 0.1. That would be 0.1. Okay. So this gives us the mole as 0.1. Now, if the mole of calcium carbonate is 0.1, what would be the mole of the one they asked us to calculate? What would be the mole of? They say, what is the mass of calcium oxide? Okay, they want us to do something here. So what would be the mole of the, before you do the math, you have to know what's the mole of this calcium oxide will also be same, 0.1. Why? Because they have the same molar ratio. So for calcium oxide, mole will be 0.1, equal to 0.1 mole. Okay, equals to 0.1. The reason is because it has the same molar ratio with calcium carbonate. So 0.1 mole. Now we calculate the mass using that same formula. This one. But before we do that, let's calculate the molar mass of this. 40 plus 16. Okay, the molar mass of this one is what? 40 plus 16. That would be 56, right? That would be 56. So the molar mass of calcium oxide is 40 plus 16. 40 for calcium, 16 for oxygen, which gives us a total of 56. So we use this number of mole and the molar mass to calculate the mass of calcium oxide. So to calculate the mass, make this one the subject, M, on top. Make it the subject. So it means you cross multiply more on this one. So mass, the mass is equal to mole times molar mass. Mole is equal to the mole times molar mass, mm, times mm. Okay, so this is equal to, what is the mole? 0.1 times 56 times 56. 0.1 times 56. So what do we get? We get 5.6, right? 5.6 gram. So this will give us 5.6 gram. So we go and look at the option, if there is such option in our work. 5.6 gram. That's the mass of calcium oxide. Which is C. Which is C in this question. Okay? So this is how it goes. You must be familiar with all these things, and you must always. Now we move to the next question. Question number 12. Question 12 says a gas series X contains 100 centimeter cube of hydrogen bromine gas. Now gas series Y contains 100 centimeter cube of carbon dioxide gas. Now the volume of each gas is measured at room temperature and pressure. Which statement is correct? The mass of hydrogen bromide is less than the mass of carbon dioxide. The number of molecules of hydrogen bromide equal to the number of molecules of carbon dioxide. Yeah, right? That looks absolute. The number of molecules will be the same because they have the same volume and same distance. So the gas in series S contains more atoms than the gas in series Y. No, there's no information confirming that. The number of moles of hydrogen bromide is more than the number of moles of this. No, they didn't give us anything for us to attend. I think the answer is B, the most correct one. The number of molecules of hydrogen bromide gas is equal to the number of molecules of carbon dioxide. Okay, at standard room temperature and pressure. So we'll go to question 13. Question 13 says, which simple cell produces the most electrical energy? Which simple cell produces the most electrical energy? You have magnesium and zinc, electrolysis of magnesium and zinc electrode, and if you want, you look for copper and maybe copper and magnesium, or copper, the one that will produce the most electrical energy. So that we need to have copper somewhere in the anode. Okay, in the cathode. We need to have copper in the cathode. So A is wrong. B is wrong. C and the answer is between C and D. Okay, because magnesium gives, okay, I think C is a better option. Okay, C is a better option for forgetting most of the electrical energy output. Forgetting most electrical energy output. We have copper in our cathode and we have magnesium ions. Okay, we have magnesium in the anode. Now, question number 14. You say when sulfur is heated, it undergoes a dash change as it melts. When sulfur is heated, sulfur, when you heat it, I think it will undergo a chemical change, not physical change. So here will be chemical change. Sulfur, okay, as it melts, it will undergo chemical change. Further heating causes the sulfur to undergo still chemical, right? To undergo chemical change and form sulfur dioxide. Yes, still a chemical change. There is no physical reaction or physical change attributed to the case of sulfur in this regard. So our answer will be chemical and chemical process. Is it chemical and chemical? Let's read it again. When you heat sulfur, it undergoes first is physical change. Before the reaction takes place, first is physical change. If you heat a sulfur as an element, first is physical change, right? As it melts, it's physical change. Then further heating, this is where chemical change will take place because it will react with oxygen. Okay, it will react with oxygen and to form a compound. So this is where chemical change takes place. So the most correct answer is C. Now we go to question 15. Question 50 says, 4 statements about effect of increasing temperature on a reactions are shown. Now the activation energy becomes lower. The first statement, it says 4 statements about effect of increasing temperature on a reactions are shown. Okay, temperature on reaction, the effect of increasing temperature on reaction. Now, when you increase temperature, the activation energy becomes lower. Is that so? Supposed to get higher, right? When you increase temperature, activation energy is supposed to. Now, the particles move faster. Yes, when you increase temperature, particles will move faster. There are more collisions between reactive particles per second. That's true. When you increase temperature, there will be more collision between reactive particles per second. There are more collisions which have energy greater than the activation energy. Yes, that's why the reaction can take place. Now, which statements are correct? I think 2, 3, 4, C. Okay, I think 2, 3, 4 is more correct than any other option. Okay, we move to question 16. Now we say an example of a redox reaction is shown. Okay, zinc react with copper sulfate to produce zinc sulfate plus copper. Now this is half equation, okay? These are half equation, this and this. It could be chloride, but I just use any of the compound, like zinc sulfate, copper sulfate, or copper chloride, or copper carbonate, but I just took sulfate, okay, before you ask for half equation. Which statement about the reaction is correct? Redox means a reduction and oxidation reaction. That's the meaning of redox. Reduction and oxidation reaction. Now zinc is the oxidizing agent and it oxidizes to copper. Zinc is the oxidizing agent, it's oxidized to copper. No, I think that's far from it, right? Zinc is an oxidizing agent. To start with, zinc is not an oxidizing agent. It's not an oxidizing agent. Zinc is an oxidizing agent and it reduces to copper ion. No. So these first two, zinc is not an oxidizing agent because zinc is just an element on its own. Okay? It says zinc is the reducing agent and it's oxidized to copper. Zinc is a reducing agent and it reduces to copper 2 ion. I think D is more correct. It's a reducing agent and it gets itself reduced to copper 2 ion. Zinc is a reducing agent and it gets itself reduced because zinc will now form a compound. This is a compound, zinc sulfate. Okay, but it's used as a reducing agent to reduce this copper sulfate. Look, this is the full reaction, for example. Maybe this one will make clarity. Plus, let's say this copper sulfate, because remember this copper ion is just a half equation. This copper sulfate to produce zinc sulfate, for example, okay, plus copper solid, plus copper. Now this is a reducing agent. Okay, it will react with this one and become this one, right? It will reduce this one and bring out this copper out here and reduce it to what? To copper ion. To reduce this copper from this copper to this copper ion, copper 2 ion. Okay, so this is a reducing agent that will reduce the copper that was here in a compound to element to ion. So that's why this is the most correct one. Okay, let's move to question 70 to save time. 70 is calculation. This one is going to take our time. Okay. The equation for the decomposition of hydrogen iodide is shown. Okay. Some bond energy are shown. Now, what is the energy change for the reaction? So we calculate the energy breaking this bond. HI. Look for HI here. There are two of it. So H to I. Energy breaking the bond is our energy in. So we calculate our energy in, which is the energy, total energy in breaking the bond. So this one, HI is 300. So we say 300 times 2. That will give us 600. Okay. This will give us 600 times 2. So this is our energy in. Okay. Energy in is the energy in breaking the old bond. Is the energy in breaking this bond in order to form new bond. So this is 600 kilojoule per mole, 600 kg per mole. Okay, to save time. Now let's do the energy out. For energy out is the energy in forming new bonds. Energy out is the total energy in forming new bond. Now which is forming this one, H to H. H2 means H to H if you are putting in bond form. H2 means H to H. Now you come to the table, where is H to H? It's 440. So you put it here. You put that. There's no number behind it, so we're not going to multiply. 440. This is 440. So there's no number here. If there was 2 at the back, we would have multiplied this one by 2. So we say plus iodine. Iodine, look at the bond, is I to I. So we say plus I to I. Plus I to I. So our I to I is 150. We say plus 150. And there's no number behind it. We just say plus 150. 440 plus 150 will give us what? 590, right? To give us 590. 590 kilojoule per mole. Okay, even if I don't write that, but you already know. Now, energy change, to calculate your energy change is the energy in minus energy out. Change in energy is equals to your energy in. Okay, I'll just put only I. Energy in minus energy out. I'll put only O. Minus energy out. Minus energy out. So which means our energy is 600 minus 590. Minus 590. That will be 10, right? But this time it's positive 10. It's not negative 10. We get 10 kilojoule per mole. 10 kilojoule per mole plus, okay? 10 kilojoule per mole. So our answer will be what? We look at the options. Our answer will be C, right? Question 17. Our answer will be C, plus 10. Okay? Now let's go to question 18. It wasn't that consuming like we expected. Question 18. Element X form an oxide XO that neutralizes a sulfuric acid. Neutralizes a sulfuric acid. Which role describe X and XO? It means X is if you neutralize an acid, is a metal. You know, sulfuric acid reacts with metal. So for H2O, you know, one of the characteristics of metal is that they can react with acid to produce what? To produce salt and hydrogen gas. To produce salt and hydrogen gas. So it's a metal. Let's say, for example, let's just assume it's sodium. You get sodium sulfate and or magnesium sulfate. Let's say magnesium. You get magnesium sulfate and hydrogen gas, right? So which means it's a metal. So element L is a metal, and what you're going to get for this one will be basic, like magnesium hydroxide. The oxide will be magnesium oxide or magnesium, yes. If you react with O, it becomes magnesium oxide. So the oxide will be a basic oxide. You know, when metal form oxide, they become basic oxide. So it's a metal and it forms a basic oxide. Okay. If it's a non-metal, it will form acidic oxide. Okay, you can revise this one in your subsequent in your notes. Okay, we move to question number 19. Question 19 says aqueous solutions of sodium sulfate and barium chloride are mixed. Look at sodium sulfate react with barium chloride to form, see, it will now be this barium sulfate. This one will displace this one, and you now get sodium chloride. Which process is used to separate a sample of barium sulfate from the reaction mixture? Which process? I think precipitation, no. Filtration, evaporation, distillation. I think filtration, because this one is not soluble. You can use filtration method. Barium sulfate is not soluble in water, so we can use filtration. If it was soluble, we would have used distillation. We would have used the distillation method. Okay, now let's move on to question 20. Question 20 says, information about element J is shown. Information about element J is shown. It has 4 electrons in its outer shell. It is a non-metal. Its oxide has a micromolecular structure. Okay. There are only 3 very strong micromolecular structures: diamond, graphite, and silicon 4 oxide. Okay. So it has a high metal point. What is J? To be silicon. Element J will be silicon. Because it has micromolecular structure, it has 4 electrons in the atmosphere. You know, it has atomic number 14. So if you do the electronic configuration, it's 2,8, 4. So which means it actually has 4 in the outermost shell. It has 4 electrons in the outermost shell. It is a non-metal. Silicon is a non-metal. Okay, it's not a metal. It's actually, to be frank, it's not a metal. It's a non-metal. Okay, so to say, at this level, it has a. This was what broke the camel's back, a micromolecular structure. So silicon 4 oxide has a micromolecular structure. It has a high metal point. So the answer is silicon C. Now we go to question 21. We go to question 21. Question 21 says, which property is shown by transition elements? Transition element. There are 3 properties of transition element you need to know. okay, in exam. Number one is that they have high density. So HD, so I put HD. They have high density. They form color compound. In paper 4, they will be asking you this question. You must know. They form color compounds. Number 3 is that they have variable oxidation state. Variable oxidation state, VOS. So you must know these 3 things about transition methods or transition elements. Every exam paper, either you find the question in multiple choice or you find it in paper 4. So you must know. Low density, no, they don't have low density. Low melting point, no. Or metals, they have high melting point. Variable oxidation state, yes. So transition element have variable oxidation. White compound, they form color compound, not white compound. Okay, so C is the most correct answer. So be prepared. You will always be asked this question. Don't let them fool you, because they will bring it every year in a different way. They will say it in a way that will make you fail, but it's definitely going to come about transition elements. Now, question 22. Helium and neon exist as a monoatomic gases at room temperature and pressure. Now, let's take a look at two statements. Statement 1, statement 2. For statement 1, helium and neon have 8 electrons in their outer shell. Helium does not have 8 electrons in the outer shell. Helium only have 2 electrons in the first case. So statement 1, I think it's not correct. Statement 1 is incorrect. This one is incorrect, meaning it's not correct, right? Because helium only have 2 electrons. The atomic number is 2. So number of protons is 2 and number of electrons is 2. But neon, that has 10 as atomic number, the first shell will hold 2, the second shell will hold 8. So this one has 8. Okay? Now let's listen to statement 2. Helium and neon are all reactive. Yes, they are all reactive. They are reactive. They are in group 8 or group 0 in the periodic table. They are all reactive. They are already balanced. First shell, once it has 2, is balanced if you don't have any other shell. So statement 2 is correct. Now, it says statement 1 and 2 are incorrect. No, that's not true. 1 and 2 are not incorrect. 1 is incorrect, but 2 is correct. Statement 1 is correct, which explains. No, statement 1 is not correct. Statement 1 is correct, but does not explain statement 2. Statement 1 is not correct. Statement 1 is incorrect, but statement 2 is correct. Yes, this is the most correct answer. Is that okay? So we move to question 23. What are possible effects of inadequate water supply during a drought? What are the effects? This one you find it either in geography, chemistry, these other subjects. Science. What are possible effects of inadequate water supply supply during drought? What will happen? Crop failure, right? That's absolute. Crop failure will be absolute, right? There will be crop failure. Wastage of water. How can you waste water when there's no water? How can you waste water during drought? Drought, no water. You see, which water will you see to waste? What else you can have? Human disease, yes. During drought, you see a lot of disease. Death of farm animal, yes. During drought. So I think I go with 1, 3, and 4. Now 1, 2, 3, no. 2 is not. 1 and 2, no. 1, 3, and 4, yes. This is my option. 1, 3, and 4. Okay, so we go to question 24. Question 24. So metal, nitrates, and carbonate decompose when heated strongly. Oh, we jump to 25. Question 24 is saying that which statement explains why galvanizing prevents iron from rusting? Zinc is more reactive than iron and corrodes in presence to iron. Corrodes in preference to iron. It looks likely. It says zinc is more Zinc is more reactive than iron. That's correct, right? That first part is correct. It's more reactive than iron and corrodes in preference to iron. Yes, let's see. Zinc is more reactive than iron and loses electron less easily than iron. Don't know. Doesn't lose electron less easily. Zinc is less reactive than iron. No. Zinc is actually more reactive. Zinc is less reactive than no. Anything less reactive is already wrong. The answer was actually between A and B, so the answer is A. Okay, now we go to question 25. Question 25. Now some metal nitrate and carbonate decompose when heated strongly. Metal Q has a nitrate that decomposes to give a salt and a colorless gas only. The carbonate of metal Q does not decompose when heated with a Bossy burner. What is metal Q? Some metal nitrates are carbonate decompose when heated strongly. Metal Q has a nitrate that decomposes to give a salt, a nitrate that decomposes to give a salt and a colorless gas only. The carbonate of metal Q does not decompose when heated with a Bossy burner. What is metal Q? Calcium, no. Copper, no. Sodium. Sodium nitrate decomposes to give salt. Sodium nitrate decomposes to give salt and a colorless gas. Okay, so we move to the next question. Question 26. Question 26. Which compounds are released by the extractions of zinc from zinc blende and by respiration? Extraction of zinc from zinc blende. Right? Extraction of zinc from zinc blende. Extraction of zinc from zinc blende. I know sulfur dioxide is released. Carbon dioxide is also released. I think the answer is between A and B. The answer will be between A and B. Now let's check respiration. For respiration, we will make it easier. Which compounds are released by the extraction of zinc and zinc blende Which compounds are released by the extraction of zinc from zinc blende by respiration? Carbon dioxide, and water. I think B is the most correct answer. B, carbon dioxide and water. Okay, and carbon dioxide, this one here. Okay, we'll go to the next question. Question 27. Which gas is an air pollutant that causes acid rain? Nitrogen. Look for any gas that has nitrogen in it. Argon, no. Carbon monoxide, no. Methane, no. Nitrogen dioxide, yes. Now let's go to question 28. Ammonia is made from nitrogen and hydrogen, and the equations for the reaction is shown. Okay, this is a reversible reaction. Okay, now the four reactions exothermic. Now, which conditions gives the greatest equilibrium yield of ammonia? Which condition gives the greatest equilibrium yield of ammonia? First of all, the temperature will be 200. The greatest yield of ammonia. Temperature is usually, like normally, temperature is 450, right? Normal. Now we want to look at greatest yield. And the pressure is 200, right? Atmosphere. Okay, now let's see. If you want the greatest yield of ammonia, which condition gives the greatest yield of ammonia? We're going to reduce the pressure a little bit, okay, and also reduce the temperature. Temperature is like a bit high. So I'll have the temperature, I'll bring it, not increase it, okay. If you increase the temperature, the rate at which this one will decompose to form nitrogen and hydrogen back will be high. So you'll be losing the ammonia that's already produced. So to reduce that effect, you reduce the temperature. Let's say we bring it down to 200. And then this one a little bit. Don't reduce it too much. Just reduce it a little bit. Let's say 150. Okay. Since there's no 180 in the option, 150, a little bit. This one will be a great condition for maximizing the production of ammonia. So I think the answer will go for B. Okay, now let's go to question 29. Question 29 says, which reaction does not occur? Excuse me. Which reaction does not occur during the extraction of iron from the hematite in a blast furnace? Which reaction does not occur? This one occurs the production of coke. Using coke, carbon reacting with oxygen to form carbon dioxide, it occurs. This coke, silicon dioxide reacting with calcium oxide to form slake. This one occurs. This one reacts with this to form monoxide, it occurs. You can check the reaction in the blast furnace. Okay? But this one, I don't think this one occurs. So our answer will be D. Question 30. Now it says, which substance is used as a catalyst in the manufacture of sulfuric acid? Occur vanadium 5 oxide by the contact process. We use the Haber process to manufacture ammonia. We use the contact process to manufacture sulfuric acid. And the catalyst here is vanadium 5 oxide. While for ammonia, the manufacture of ammonia, the catalyst is iron. So iron is for when you are Haber process, when you are manufacturing ammonia. Okay, don't make the mistake. Don't mix them. Not nickel, not phosphoric acid. Phosphoric acid is used as ammonia in the hydration of ethene to produce ethanol. Okay, vanadium 5 oxide is used as a catalyst in the contact process. All these things you have to be very, very familiar with them. Now let's move to question 31. Question 31 says, metal X is a good conductor of electricity and is used for electrical wiring. Oh, used for electrical wiring, okay, like copper, aluminum, all those ones, right? Metal Y is used to make an alloy which is resistant to corrosion, is used to make cutlery. Like iron, right? Iron, steel, and so on and so forth. Metal Y is used to make alloy, which is, it cannot be steel, it's iron. Okay, because it's used to make alloy. Steel is already an alloy, but something to make alloy is Y, which is iron, and is resistant to corrosion and is used to make cutlery. Yes. Metal Z is light and strong and is used in the manufacture of aircraft. Aluminium. This one will be aluminium. For electrical wiring is copper. Okay, for wiring is copper. So copper, aluminum, iron, and aluminum. I think B is the answer. Am I right? I think B is the answer. We go to question 32. Question 32. Now the formula of two compounds of manganese are manganese 4 oxide and manganese 7. 4 and 7. This is manganese 4 oxide and this manganese 7 oxide. Potassium manganese 7 oxide, okay? Now in these two compounds, the oxidation state of potassium is +1. And the oxidation state of oxygen is -2. What are the oxidation states of magnesium in each of these two compounds? Why they call it manganese 4 oxide? This one will be +4. Okay, why they call it manganese 4 oxide? This one, magnesium here, manganese here is +4, and manganese here will be +7. And that's why they call this one manganese 7. Okay? So the correct answer will be D. Now, which statement? Question 33. Question 33 states that which statement about calcium carbonate is correct? Which statement about calcium carbonate is correct? Calcium, okay, carbonate. Now this is a limestone, right? You know, right? For making cement, for making. Which statement about calcium carbonate is correct? It is made by thermal decomposition of limestone. Yeah, that's correct. Right? You say which statement is correct, right? Which statement about calcium carbonate is correct? Right? Okay. It's not, because itself is a limestone, so it cannot say it's made by thermal decomposition of limestone. You see the contradiction? They put it in a way that will fade. Okay? Itself is a limestone. It doesn't say it's made by thermal decomposition of limestone. No. It is used to neutralize alkali soil. No, itself is alkali. So, not used to neutralize alkali. You use acidic substance to neutralize alkaline soil. It is reactant. It is a reactant in the test for carbon dioxide. That's not true. How can it be a reactant in test for carbon dioxide? This one is completely senseless. This one. It is used to remove impurity in iron extraction. Yes, we use this one to remove impurity from the extraction of iron in the blast furnace. Okay? So that's the most absolute. Is it most absolute? Yeah, I think it's the most absolute. Now let's take a look at question 34. Now question 34 says that ethanol, now we are in organic chemistry. Ethanol is reacted with acidified potassium manganese 7. You see the name? Acidified potassium manganese 7. The one we saw just now, KMnO4. The one with equation where I told you is 7. MnO4. It's called acidified potassium manganese 7. That's the name. Okay. So ethanol is reacted with acidified potassium manganese 7. Now, which row describes the type of reaction and the type of organic compound formed? Type of reaction will be oxidation reaction. Because if you bring ethanol here to anything with this one is oxidation reaction. It's oxidation reaction. So the answer will be between A and B. Okay, C and D will be wrong. It's not dehydration reaction. So and then if you bring ethanol to become ethanoic acid. If you react with ethanol to form ethanoic acid, which means it's a carboxylic acid. So our answer most likely is A. Our answer is most likely to be A. Because if you react with ethanol, we can say C2H5OH. Okay? If you react this one with ethanol, the one atom of OH, one atom of oxygen here, we join here, we become like COOH. We have two oxygen, so we become a carboxylic acid. So the answer is A. Now we go to question 35. Now the diagram shows the structural formula of 4 compounds. Structural formula of 4 compounds. This is 1, 2, 3, 4, 5. This is pentane. Okay, this is methyl. 1, 2, 2 methyl. 1, 2, 3, 4, 5. 2 methyl pet 2 in. Okay. This is 2 methyl butane. This is 2 at carbon number 2. If you start from this side, 2, you have this methyl 2-methyl, 1, 2, 3, 4, 5, 13. Now, which two compounds are structural isomers? Which two compounds are structural isomers? Okay, 1 and 3, because this is a 13 and this is 2-methylbutene. 1 and 3, they are structural isomer. 1 and 3, so I go with A. Okay. What they did here, they took one like this one, this thing. They put it at carbon number 2 here. They put it down here. This hydrogen, they put it on this end here. Take this hydrogen, put it in this end. Take the whole of this, put it down here. Put it down here. That's what they did here. Or put it down here. That's what they did here. So they are isomers. They are called structural isomers. Okay, now let's go to question 36. Question 36. It says, which statement about alkanes is correct? Alkanes, they burn in oxygen. Of course, they burn in oxygen. They burn in oxygen, like methane. You know methane, right? Methane burn in oxygen to produce carbon dioxide. They are fuel. They are fuel. They burn in oxygen. They burn in oxygen. Okay? I just took an example, methane, the first member of the alkane family. React with oxygen to produce carbon dioxide and water. To produce carbon dioxide and water. To produce carbon dioxide. If there's excess oxygen, in presence of excess oxygen, to form carbon dioxide and water. If there's little oxygen, if the oxygen is not enough, it will form carbon monoxide, which is dangerous in our environment, which pollutes our environment. Okay, so yeah, that's it. So they burn in oxygen, that's absolute. They contain carbon, hydrogen, and oxygen. Alkane family don't contain oxygen atoms. Okay. It's only carbon and hydrogen, they are hydrocarbons. They contain only carbon and hydrogen atoms. They contain double bond. They don't contain double bond, they contain only single bond. Why? Because they already balanced. They have everything. They don't contain double bond. It's only 18 that contains double bonds. They don't have a double bond. So that's not correct. They don't contain double bond. This is not correct. This is not correct. They don't have hydrogen atom. They contain ionic bond. No. They don't contain ionic bond. The bond in oxygen is the most absolute. So 36 is A. 36 is A. Now 37, how much hydrogen is needed to react completely with 0.2 moles of butene? 37. How much hydrogen is needed to react completely with 0.02 moles of butene to make butane? Okay, this one we have to remember the formula that relates mole and volume, right? Mole is to volume, right? Mole is volume over 24. Over 24. Right? Mole is here. I hope this formula is correct. Mole is volume over 24. Is it how much hydrogen is needed to react completely with 0.2 moles of butene to make butane? So we know the mole. We calculate the volume. So 0.02 times 24 first. Let's see what we get. 0.48. So you just say the volume of hydrogen needed, because they are in same molar ratio, will be the mole times 24. times 24 decimeter cube. So the mole that has been given is 0. They have same molar ratio. So this molar ratio for Butyl is same for hydrogen. So you say 0.02 times 24 times 24. We get 0. In decimeter, we get 0.48. 0.48 decimeter cube. Okay, so decimeter cube. So we look for the options. We look for the option B. Right? So that will be our answer. We move to the next question, question 38. Question 38. Question 38 says, what is an advantage of the fermentation process for producing ethanol compared with the catalytic addition of steam to ethene? What's the advantage? Fermentation requires less heat energy. Yeah. Ethanol from fermentation needs to be distilled. No. Raw materials for fermentations are non-renewable. No, they are renewable. The fermentation process is carried out in batches rather than several. No. So require less heat energy. I think A will be absolute. Okay. Now question 39. Question 39 says the structure of a synthetic polymer is shown. Okay. Now the structure shows that it is a dash. It is a dash, and it is formed by dash polymerization. Obviously, it's a condensation polymerization. It's not addition polymerization. So the option will be B and D. This is a any polymerization. Addition polymerization is when ethene is added to itself. Ethene is added to itself. Okay, to form a giant molecule. That's addition polymerization. But condensation polymerization is when we have here this type of structure. So the option is so now NH is amide group. This is an amide group. So which means it's a polyamide. It's not polyester. It's a polyamide. So this answer is B. Okay, it's an amide group. So the answer is B. It's not polyester, it's a polyamide group. Okay. Now we go to the last but not the least. Say which substance is a natural polymer? Ethene is not a natural polymer. Terylene is not a natural polymer. Liner is not a natural protein. You know the natural ones are protein, carbohydrate, and fat. So these ones are called synthetic polymer. All these ones are called synthetic polymer. The natural one is protein. So with this, we've come to the end of our today's class. Thank you for joining us.